Hi, I'm Ray Ernst. I'm an assistant professor here at Hilbert College. I teach in the Forensic Science Crime Scene Investigation Department. One of the courses I teach, one of the sections is on bloodstain pattern analysis. And the premise of the course is to prepare future law enforcement officers, attorneys, crime scene investigators for how to examine blood evidence at a scene. And we go over some basic components. And one of the first components we go over is how blood behaves outside of the body. That's what we're concerned with, especially at a violent scene. Blood has very cohesive properties to it. The molecules of blood want to hold together. They want to stay together. So often we think of a scene as a violent scene where someone is either seriously injured or killed, there's going to be a lot of blood all over the scene. And that's not necessarily so. I brought some instruments in today. Okay, here's a sharp instrument. Simulates a knife. And if I dip it into some simulated blood here, which has a viscosity or thickness very similar to actual blood, probably a little thinner, and I pull it up, you're going to see a few drops come off initially, all right, but then it stops, okay, and then only every once in a while something will drip, all right. Again, you would have to dip it back into the blood to get more blood to come off of it again. Okay, but quite a few drops initially come out, but then it holds to the surface. Again, those blood molecules want to hold together. So if someone has a knife and they just stabbed another person and they're standing still at a scene or just moving slowly, not a whole lot of blood's going to drip off that knife. You get a few initial drops and that'll be it. If you see a lot of drops coming off, that's probably because a lot of motion going on, flailing the arms or running through the scene. The type of instrument matters. If I take a hammer, I put the hammer head in here. Remember the same properties again, and we don't get any blood dripping off. Okay? And you probably have to stand there a while before the first drop's going to come off, the second, and maybe that'll be it. Again, though, if we put motion into it, then you get some drips coming off. All right? And that's important for the students to understand because they initially think that whatever blood scene they go to, there's going to be a lot of blood. All right? The other thing we go over is there's three different types of blood spatter we look at. First is low velocity. Low velocity is passive drops. Okay? And passive drops are just blood being pulled by gravity, dripping down to a surface. Just like that. And when you look at them, they just form nice circular shapes. If you measure the width and length, they come out to be the same. Okay? And we get a lot of this at a scene. All right? So if someone's standing in one place, holding a weapon, or if they have an open wound, they may be dripping where they're standing. What it really tells us also is that if someone's moving slowly, and they're just walking, you're going to get drips. All right? And again, they're just going to be circular drips, so. And it's going to look just like similar to someone standing in place. But if someone starts moving quickly, and brisk walk or running, now those shapes are going to become elongated. And they tell us quite a bit. They tell us now that the person was either walking fast or running. It may show them exiting the room. It'll show us direction of where they were moving and give us a lot more information. Okay, and that's where we begin. And then there's also medium velocity patterns and high velocity. And we'll go to another room in a few minutes. We'll show you a simulated scene that we created, and we'll go over the other patterns. Okay, so now carrying on from the lab, now we're in the bloodstain room. Okay, we create this for the students so they can take what they've learned in the classroom and apply it to a simulated scene. Okay, and we do this for bloodstain pattern analysis, and we do it for their photography course. They'll come in here and photograph the stains as well, because that's all part of the investigation. Carrying on from where we were before, we talked about those passive blood drops. And as you can see here, we have some nice passive blood drops, just dripping at a vertical 90-degree angle to the floor, dripping off an item, dripping off a wound. Okay, they're different sizes because the volume of blood is different. We can't, we know what the volume of blood was, but we can tell at least it was dripping off something. All right. We have a number of stains here. We have transfer stains. Okay, you can see someone walk through some blood here. We have a stain here where there's a void here. Something was there, and the blood went around it, and that item was removed. It's called a void. Here we have someone was striking into a blood source. It's either blood that was on the surface pooled here, or it was on an object and someone was striking into it, stepping into it. Energy was applied there, and you can see the blood is forced out in all directions. Okay, gives us some more information. All right, so the students would come in here and they look at the floor first. Of course, we removed all the evidence from it. If there was a body in here or other evidence, they collect that, and then they make their determinations from what they observe on the floor. Okay, next what we do, we talked in the lab about the passive blood drops, the low velocity drops. This is medium velocity. And medium spatter, this is what we look at primarily when we're trying to separate out events, what occurred in a room. So we look at a room like this, if we went all around the room, you're going to see these different types of patterns around the room. And we may be able to separate those out into different events and tell you how many different events happened. Someone struck into a blood source somewhere in this area, and the blood was projected onto the surface. And that's what the students did here. They looked at individual blood drops, okay? And you can see on the drop, it's elongated, and it has a tail on it, okay? That tail is showing them direction. That means that that blood drop is going this direction. It's following the tail, all right? So they're picking drops that look like they probably belong to a similar event, and they trace a line through it. And you can see they grabbed a bunch of different drops, and they all converged in this general area called the area of convergence. All right? What they do next is the further photographs. They put a scale in there, and they photograph each drop, and it gives you size as well. Then they compute the angles of the drops, all right, with some basic trigonometry. They write the angles next to it. You can see 10 degrees, 12 degrees, 10 degrees, all of them very close, all right? And then we do a method called stringing, where they actually will tape a piece of string here to the drop, carry it out from that drop, that surface, at whatever degree angle it's supposed to be, and they'll tie it off to a pole that's out in the center here. All right? And all these strings will come into a general area, and these ended up right around here, okay? And what that tells the students is that some event happened, someone struck into a blood source, whether it was an open wound on a body or something where there was a volume of blood, they struck into it, and the blood went here. So it tells you height. It tells you height and how far away from the wall that event occurred. Okay? And then they carry on. They go from there, and they'll find another one. Okay? And they'll keep going. But you can see you need really good drops, really well-defined drops to do this. If you don't have that, you can't do it. Okay? You don't want to over-interpret. You don't want to overreach and say something that you can't physically show, especially when you talk to a judge or a jury. And have to be able to demonstrate it. Okay. This is an example of cast-off now. Cast-off would be, say someone has a weapon, and they have their weapon, and there's a volume of blood on that weapon, and now they're striking someone, and they're swinging it back and forth. The greater volume of blood that accumulates on that weapon, the more likely there's going to be cast-off. It's going to go on the walls, may go on the ceiling, go on the suspect, the victim as well. And here we see an example of cast-off along the side of the wall here. Okay, so someone's along the wall here, and they're flailing the weapon with the volume of blood on it. It's casting off the blood. And then directly behind it here on the wall, you see circular drops. Okay, very similar to our passive drops. Remember, I said they're striking a surface at a 90-degree angle? Well, that's what's happening. It's hitting this wall at an angle, okay? But this one is hitting direct, okay, because it's coming off the weapon, and it's hitting directly behind the suspect, and it's hitting the wall here, and you have nice circular drops. So the students, when they see something like this, it gives them a good idea of what cast-off looks like. Okay, and lastly, this here is an example of high-velocity blood, okay? When you think high velocity, think of a gunshot, okay, a gunshot wound, all right? When someone's shot, it's almost like a mist, like a spray, high velocity striking onto a surface. Now, all the calculations we did and areas of convergence we did with medium velocity blood, we cannot do with this. Okay, we would document it. We'd make note of it that we have high velocity blood patterns in the crime scene, and we document all those around the scene and put those in our sketches. This gives you a good idea of what it looks like.